Hello, I'd like to talk to you about regression analysis. Regression analysis originally got its name from Francis Galton, who's a 19th century scientist who's looking at people's heights. And so what he found is if you had really tall parents, their kids tended to regress toward the mean. Their kids tended to be shorter than them. And probably found that, you know, parents that were short had kids that were taller than them. So kids tended to go toward the mean. Now, likewise, I have kids, and my kids tend to be shorter than I am. So proves, actually does not prove, but would be a case of regressing toward the mean, since I tend to be a little bit taller than the average. Now, whether they stay shorter, that remains to be seen. We'll find out later because my parents were taller and I was taller than they are. So it doesn't fit all the time, but that's where it got the name. So now what we are talking about with regression analysis is we're trying to determine the strength of relationship between a dependent variable, usually called y, sounds like an equation for a line, doesn't it? And the independent variables, the x's. Well, what do we mean by dependent? Well, that's notice, anytime you do an equation of a line, right here, notice we determined y based on x. That's why it's y is dependent on whatever value I give x. So down here, if I give, looking at correct answers, and I set x and my x would be hours studied, my y would be number of correct answers. And so if I put in 0 for the hours studied, well, my slope, we assume somebody would get about 41 points right. And so number of correct answers is determined, or is dependent, which is why it's called a dependent variable, on the value we put in for x. And so we call x independent because we just put it in there to determine y. How's that for independent? And so really what we have is an equation for a line, in this case of a simple linear regression. And we just told you y is our dependent variable, x is independent, b0, which would be the 41 here, would be our intercept. 5.02 would be our slope. And the next thing we want to look at is r squared, coefficient of determination. R squared shows the proportion of total variation explained by the regression line. Well, what does that mean? Well, notice I put some points down here. And in fact, let me get my drawing tool. And I like big dots. Now let's do this one. So what we have here is students, and we have it. So like here's a student who didn't study and got a low score. Here's a student who studied maybe an hour, got a higher score. Another student who studied an hour, got a much higher score. And so it looks like there's a positive relationship between hours studied down here, which is our independent variable, and our y is our number of correct answers. And here I copied over again, number of correct answers we're assuming is equal to 41 plus 5.02. And so we're trying to fit a line if we're doing a regression, and we'll bring in r squared in a second here. We're trying to fit in a line that best fits these points. Here's a person who studied a lot of hours, did much better than not studying, but here's somebody who didn't quite study as many hours but did a lot better. So this is called a scatter plot. Looks pretty scattered, doesn't it? So a scatter plot. And so what we're trying to do is, in fact, let me get an equation or a line here. We're trying to fit a line to these scatter plots. And if I fit it right, it looks like right there, and then right like that. Does that look like it's the best fit that fits those points? That gives me the least error. I think that looks pretty good. Fit that, could be down here. No, I think this point up here brings it up a little bit higher. Maybe right there. That's now, neat thing about statistical software is that they make it nice and exact versus mine. Just let's see how close I can draw a line. Now, next thing we want to do, so there's our equation. There's our line that I think best fits that, or at least pretty close. And now if I asked you, well, what is that r squared? So what this is implying is, as it says up here, if this is r squared of 0.68, so if it's 0.68, It's not 0.9217, so it's 0.68. This means that 68, does that look like an 8? 68% of the total variation in our case, test scores or correct answers, can be explained by hours studied, the x value. So if the x value, as I just said, is hours studied, then 68% of test scores can be explained by how many hours a student studies. Well, that's pretty high. And if this had been 92.17, like I crossed out, that would imply over 92% of how well you do on the test is explained by how much you study. Now, I don't think it's that high. Some students can study just an hour and do really well. Other students need to study like 12 hours or 11 hours. Now, with this equation, if I study 12 hours, I should get a little over 100%, 101% on the exam. Well, or 101 points. And I'm going to assume that it's a 100-point exam. So, obviously this line only fits in the relevant range where I have the data, so not outside of it. And so let's summarize. So a regression analysis is we have these data that we've collected, and we're trying to fit the line that best fits these points. And so this line hopefully best fits these points. Gives us a line that we can use to predict. And so if somebody tells me I studied for 2 hours, how well do you think I'll do? Well, I'll take 41 plus 5.02 times 2 hours, and that should be, I think you're going to get 46 point, it's supposed to be a point right there, 02. That doesn't look very good, does it? 02. It's choking me up. The student didn't study more. So let's just rewrite it all. Maybe I need to study how to write. 46.02 points. They did not do well. They need to study more, or study more effective. Now, this is assuming this equation is correct, and obviously there's a lot of variations where that student may study another hour and be this person up here, or they could be this person way down here. They're not studying as effectively. So here we're just looking at hours studied and correct answers. Now, if they had studied for 10 hours, notice each hour gives you an extra 5.02 points. It's supposed to be 2 times 10 plus 41. 10 hours should give you an A. Give me an A. There it is. You did well on the exam because you studied. So keep studying.